Hi you guys, it is Miss Everly here. We're going to talk today about rational numbers. Things that are rational, things that seem to make sense. So the actual definition of rational numbers is a number that can be written in the form a over b, where a is an integer and b is a non-zero integer. So you might be like, what the heck does that mean? So I'll give you some examples. The number like 2/5 is considered rational because, there we have it, 2 is an integer and 5 is not 0. This number is a fraction. If something can be written as a fraction, it is a rational number. It's something that can make sense. 0, we can make sense of it. 0.3 repeating. Can you make that into a fraction? Yes. And if you know it off the top of your head, 0.3 repeating is actually the fraction 1/3. So it's rational. We know what's happening. -6, could that be written as a fraction? Yes. -6 is -6/1. So that's considered rational. Something else that would be rational, 3.5. Because I could write that as one single fraction. That would be over 2, what would it be? 6 plus 1, 7/2. So anything that can be written in fraction form is considered rational. So let's start with some rational examples. We're going to look at 3 examples, and they're going to go from mild to spicy. So let's start with something that is mild. No spice, so you're going to be feeling good. Okay? So let's look at and compare the rational numbers, -4.9, and we're going to compare that to -4.3. This is considered mild because they're already both decimals. So what I want you to do always is try and picture this on a number line. These are both negative, so if I look at 0, they're going to be below 0, right? They're going to exist on this side. And which two numbers, which two integers do these two numbers exist between? So on the negative side, I'm going to redraw my number line. These two exist between not -1 and -2, but -4 and -5. These two numbers exist somewhere in between here. And we want to know, is -4.9 less than -4.3? Is it less? Or is it greater than -4.3? So let's figure this out. So -4.9. Well, -4.9, that's super close to -5. So I would say -4.9 is about right there. And -4.3, well, that's getting closer to -4. But it's still over it, so I'd say it's about right there. Because -4.5 or -4.5 is in the middle somewhere. So -4.3 would be here, -4.9 would be here. So if we remember that 0's over here, way over here on the right, that means -4.9, that's situated right here, is farther from 0 than -4.3. -4.3 is actually closer to 0 than -4.9. So -4.9 is farther away, meaning it is less than -4.3. All right, if you're like, oh my gosh, I did not understand that, replay that part of the video, okay? Because I am going on to medium spice. Something that's medium spice. Woo! Okay, so that means we're stepping it up, and we're stepping it up into not decimals, but mixed numbers. Okay, and I've thrown at you negatives. So we're going to compare these things. I would start the same way. From 0, where do these numbers exist? They both exist on the negative side. Then again, I'm going to go from there and say, what two numbers do they lie in between? They both are -3.5, -3 3/4. So they actually are on over -3 all the way, but not over -4. So they exist somewhere in here. And then it would be a matter of, do you know your fractions off the top of your head? If you don't, then I am going to have to take 1/2 and divide it down here. And I'm going to have to take 3/4 and divide that. So I'm going to divide them at the same time to figure out which one's farther along, which one's farther away from 0 on the number line. So I have 1/2 that I'm dividing, and I have 3/4 that I'm dividing. And remember, I'm going to do it at the same time because I want to see if I can just stop and I see if I have something that's different from each other. So 2 does go into 10 perfectly, and maybe you already knew this one off the top of your head, hopefully, that 1/2 is 0.5. Okay, so I know that -3 and 1/2 is really -3.5, which exists halfway between -3 and -4. All right, now I'm going to check 3/4. So back here to the division. 4 does not go into 3, so I attach my decimal, add in a 0. 4 goes into 30. Let's see. You're trying to think of this in your head before I get it. I know my facts, so I already have it in my brain, but I'm letting you have some think time. Ends up being 7. Does not go in perfectly, but you know what? I'm going to stop because the 7 is different from the 5. I already know that the 7 is greater than the 5, meaning it's going to be farther along. So this -3 and 3/4 is -3.7 something, and 7 is farther, closer to the -4. So there's where my two numbers lie. I have -3.5 right here, and I have -3 and 3/4 approximately right here. Meaning that I'm going to say that -3.5 is what compared to -3 and 3/4? So -3.5 is actually closer to my 0. It's going to be a little bit warmer than -3 and 3/4, so it's a little greater than -3 and 3/4 because this was farther away from 0, so it's going to be less. Woo! That was a tough one, but it was only medium. So let's try it spicy. If you're like, oh my gosh, I am not ready for spiciness. Well, it's going to be okay. It'll just be a lot of learning moments for you. So here's the spicy problem. Let's do it in pink. So I have the numbers -8, -5 and 1/3, -8.22, and -8 and 1/3. You're like, okay, Miss Everly, what are you having us do with them? Put them in order. From least to greatest. So I'm going to put 4 slots down here. This being the smallest, the least, and this being the greatest of them all. So just like in class, can you use your number sense powers and just look at the numbers up there and know which one is going to be the least? Or do you know off the top of your head which one's going to be the greatest? Can you figure out one of those? Any of them? Okay, I see they're all negative. Do I have a negative that's closer to 0 that I can see off the top of my head without doing really any math, just number sense in my brain? I see one of them that is closer to 0, and that's this one. 5 negatives is closer to 0 than 8 negatives. So I'm going to place that one over here at the greatest. -5 1/3 is the closest to 0 that we'll get. Okay, got that one. So that one's out the door. All right, how about, can we figure out any other ones? Well, I can. I know something that's going to go right here because I know one of these numbers is closer to 0 than the other two. So I see this one's -8. This one's -8 and something else. And this one's -8 and 1/3. So this one was just strictly negative 8, meaning it's going to be closer to 0 if I think on the number line, negative 8. There's negative 8, whereas negative 8.22 is farther away. Negative 8 1/3 is farther away. So I'm going to say negative 8 goes here. So I'm done with that one. Meaning that one of these two is going to be the smallest one up there. What's nice is this is already a decimal. So I just have to change 1/3 into a decimal to figure this out. See which one is farthest away from 0, and that'll be my least number. So let me rewrite these two. I have negative 8.22 and negative 8 1/3. So we need to convert that to a decimal. I already know that this one is 0.22. So 1/3 divided out. Maybe you know this one off the top of your head. 3 goes into 10 3 times, and it doesn't go in perfectly, but you know what? I can stop because I can tell this 3 is bigger than the 2. So when I look on the number line between negative 8 and negative 9, negative 8.22 is closer to that 0 mark over here than negative 8 1/3. That's going to be right here. They're close to each other, but the 3 is bigger than the 2. So it's going to be farther away from 0 on the number line, meaning that negative 8 1/3 is going to be my least, my smallest, my farthest away from 0, with negative 8.2 taking that second place. Thank you for watching. Have a lovely evening. And hopefully I won't see you in lunch detention. Adios!